Sorry. Yesterday we talked about two laws, Charles' Law and Boyle's Law. And if you'll look up by Leprechaun Man, I think that you'll see them up there. And it says Charles was a hothead. That's how I remember that Charles' Law is about temperature. And so Charles' Law said as temperature increases, volume increases. If we took the reverse of that, as temperature decreased, what would volume do?
Decrease.
Because that's a direct relationship. That means as one thing increases, the other thing increases. As one thing decreases, the other decreases. Make sense? Down below it was Boyle's Law. And that said that the pressure of a gas increases, the volume decreases. And we said that that was an inverse relationship. So in other words, I took this particular syringe, I filled it up with air, and I said, if the volume decreases, that means that the pressure is increasing. And then I said this by the reverse, if the volume increases, the pressure must be decreasing. And I know I showed you this, but I'm going to show it again because I've got the camera here today. And so we've got this flask, and it's filled up with a little bit of water, about 100 milliliters or so, and we've got this balloon on there. And right now we knew that the gas and the air inside of the flask has kind of expanded because of heat. Yeah, absolutely. We increased the thermal energy in there, and so now we're going to take that thermal energy and we're going to get rid of it and hopefully not break. Oh no! I'm melting. Doesn't really matter how many times you see it, does it? It's still pretty cool, isn't it? Yeah. And so if you look at it, and we talked about the strong lung people in here. Who did we pick on yesterday? Who was it? Braden. Braden, how'd that work for you when you tried to blow? Yeah. Hopefully you didn't blow a blood vessel in your head or anything. So I had some people trying so hard earlier, I was getting pretty worried about them. But so we are going to work with this crazy looking apparatus. Okay. So first of all, I'll have you cut it. Okay, ladies and gentlemen, if you take a look at the sheet that's in front of you, we are looking at student worksheet for experiment number 1, and you'll see this apparatus. This is A. This is B and C. I think C is actually the little O-ring. It's a rubber O-ring that's in there. And then this is D, and this is E, and this is F. E is actually this thing called a check valve. Anybody know what a check valve is? This is where I want you to write in your notebook the answer to question number 1, which says, what is inside the bell jar now? When I do this, I'm going to pull it to the 60 milliliter mark. There's now air in this syringe. The question is, where did it come from?
The check valve.
So number 3, we're going to let go of this now. And you're going to tell everybody how hard it was. So pull it out, okay? Okay? So now turn around and tell everybody how hard was it.
It wasn't that hard.
It wasn't that hard. That's a direct quote from my friend JC. Thank you. All right, what I'm going to have you do is I'm going to have you take this and I'm going to have you pull it out to here, or all the way or so. And then I'm going to have you push it back in here real quick. And we're going to do that 5 times. So we're going to go 1, 2, 3, 4, 5. Got it? Okay, what I need you to do is I need you to pay attention to how hard it is to pull this out, okay? And does it change? All right.
It does get harder.
It did get harder. Okay, so that's what JC said. She said it got a little bit harder, a little bit, but I want you to remove the bell jar. Well, that wasn't hard, was it?
No.
No. Okay. Now, I'm going to put a little bit of a vacuum inside of there. I'm going to take some of that air out of there, okay?
Okay.
It was just one, it was like 60 milliliters of air that I took out of there, okay? So now there's a little bit of a vacuum. That means that some of the air has been removed from there. Do you think that it's going to be harder now to get it apart, or do you think it'll be easier?
A little harder.
A little harder. Okay, so what I'll do is I'll hold the base because I don't want you to break that part. So you go ahead and pull that off from that. Okay. Was it a little harder?
Yeah.
Awesome. All right. So now I'm going to go and I'm going to put in I'm going to put in 10, okay? Or I'm going to take out 10, I should say. So now I've taken out about 10 pumps with the syringe. So now I'm going to hold the base. You think it'll be harder or easier? Oh, hold on.
Way harder.
Way harder. Okay, go ahead, give it a shot.
Oh.
Are you trying? I'm just checking. Don't hurt yourself. I don't want you. Don't pop a blood vessel or anything. Okay, we get the idea. But you know, what if we take that vacuum and we allow that vacuum to fill back up with air? Listen for a moment. Now, what we've got here now is a balloon. I'm going to put that balloon in there. You'll notice it's partially blown up. What do you think is going to happen? Okay, so what do you think is going to happen? Let's find out if you're right. Are you ready? Here we go.
Stretching it. In the jar.
Did you get it right?
Yep. No.
I got the opposite.
Okay, so what's going to happen now when I take this valve off? What's it going to do?
Shrink. That's so cool.
All right, so that was a balloon.
Marshmallow. I've seen it have like a marshmallow.
What's this?
Oh, it's a
What?
suction.
Suction cup. Okay, so when I do this, bless you. Bless you, but that's it. No more. When I do this, how come that suction cup stays there? Even though I turn it upside down and gravity's pulling on it. Bobby? It is. Yeah, awesome. It's a mini one. It's like a mini vacuum. Okay, and we know it's not that great. We can peel them off, you know. Usually you put all kinds of things up on your car, windshields and stuff like that. Sometimes you hang stuff in your kitchen off from a window or whatever. But we're going to stick this one on here. I'm going to put the bell jar on. I'm going to turn it upside down so you can see. No tricks. Gravity's pulling down on it. That's a little mini vacuum that's underneath that suction cup. What's going to happen when I put this bigger vacuum around that mini vacuum? What do you think, David?
It's gonna pop up.
Let's see. Did you see it? All right. Next, we're going to try this one. Remember this one from Save the Penguins?
Yeah.
Bubble wrap. What do you think is going to happen when we put the bubble wrap in there? If you want to get closer, you can too.
The bowls are so big.
Whoa.
Let's try it one more. No, there's a couple. Like 4. How come I didn't hear them pop?
Because the air was just sucked out of them.
The sound doesn't travel inside a vacuum.
Oh, check out the big brain on Sam. Sound doesn't travel through a vacuum very well. And even if it's a vacuum like this one, sound doesn't travel very well. So what about this one? We got to try this one.
I can't eat it.
Of course you do, Indigo. Of course you do. What do you think? Let's give it a shot.
Oh my god,
You guys ever see Ghostbusters?
Yeah.
Stay Puft Marshmallow Man? That's how they made him. My friend Mr. Stangle said that if you guys wanted to save money, you could get little marshmallows, you could do this to them, and then you would have big marshmallows. I don't think that would work.
No.
Well, that's a good question. What do we think? Do we think it's going to stay that size?
It's shrinking.
Are you ready?
Not big enough. It shrank.
Can I try that? Can I eat it? Expand those. Oh,
I'm going to get some hot water from the tap, and I'm going to ask a question that you're going to say duh to, but is this boiling?
No.
Duh. Okay. Why?
Because it's not hot enough.
Okay, what would I need to do to make it boil?
Make it hotter, 100 degrees Celsius.
Okay, awesome. I would need to make it hotter, and specifically 100 degrees Celsius. Okay, so I've got this water, and it's about 94 degrees right now. That's exactly what I want it to be.
that's hot.
Yep, 94 degrees. And I'm actually going to heat up this little container. So I'm going to get some of this water in here. I'm going to heat up this little container. And I'm going to ask you the same question I asked you before. Is this water boiling?
No.
Because
It's not hot enough.
it's not hot enough. Now I'm going to ask you another question. I don't think you'll say duh to. You might say I don't get it, but that's okay. Do you think that the pressure of air pressure, do you think that the pressure of air makes it easier for that to boil, or do you think it makes it harder?
Harder.
Wow, that was awesome. Okay, well, let's find out if that's true, because what we're going to do, you know what we're going to do.
Put it in the bag.
We're going to put it in this little bell jar, and we're going to get rid of the air pressure in there, and we're going to see what happens. Now, I want to ask you, am I adding any thermal energy to this system?
No.
Okay. Do you see it boiling?
Yeah.
Do you think it will stay boiling if I undo this?
No.
It's magic.
Okay, so now, do you think it'll still go back to boiling if I take
Yes.
the air out again?
It's moving.
I think it's done the opposite.
Oh, the water's in the tube.
I thought it would have done the opposite. And take the
That's pretty cool, isn't it?
I want to get one of these.
Yeah. So if we can take that air pressure and get rid of that air pressure, it makes it easier for that to boil.